Good afternoon. My name is Mark Emerton. I'm Senior Innovation Lead for Robotics and AI at Innovate UK. Now, in this session, we will hear from the projects funded by Innovate UK in the space robotics domain, each from high-profile companies in the space sector, high-profile internationally, and we'll also hear from the Fair Space Academic Hub. The last speaker will present on the fascinating area of in-space solar energy, which is not an Innovate UK project, but it's a BASE-funded feasibility report. In the collaboration session that follows, we'll hear from all of our video presenters and the Satellite Applications Catapult for a more general discussion on where in-orbit and planetary robotics go next. So to start the session off, we have Jason from Astroscale. Earlier this year, launched their LED mission, the world's first demonstration of commercial debris removal. Let's hear from Jason.
Today I'm sharing some of the activities Airbus is undertaking in the field of space robotics and in space manufacturing. Currently we're looking across three main strands. The first one is about identifying future needs across markets: telecom, planetary exploration, human spaceflight, science. We can actually see from these needs that they will require some time, larger structure than what we can launch through today. So there's a need to actually take some of these needs and refine mission concept to see how we can actually build vast arrays, set up in-space factories, payload hubs, or service platforms. And finally, the final piece of the jigsaw is about developing these critical building blocks: in-space mobility, new manufacturing processes, and space manipulators. One of these mission concepts is RISMA, supported by Innovate UK ISCF. It featured in-space manufactured elements, prefabricated active payload elements, and a robotically self-assembling large-scale structure. We're talking about 100 meters across. As part of this project, we perform a number of breadboard activities, aiming to functionally demonstrate some of the key technologies, including the manipulator, the assembly concept, and mobility. More recently, we're now involved in the H2020 period project. This one is focusing on orbital factories, and especially a concept that will be deployed on the ISS on the Bartolomeo platform. It's aiming at demonstrating the assembly of a spacecraft and its reflector, and will involve about 10 partners. This particular concept involved two manipulators working together. And that leads me to some of these critical building blocks, the space manipulators. Over the years, we developed a number of technology demonstration models that we've synthesized into what we call VISPA, the Versatile In-Space and Planetary Arm. It's been designed from the ground up to be cost-effective, scalable, and modular. It will feature compliance control and has gone through an accelerated development leading to a TRL6 later this year. And that includes environmental testing. It's been designed to support high duty cycle in space and planetary activities, and it's currently the baseline for this H2020 project. So it's been very much a whistle-stop tour here of some of these activities, but should you need more information, do get in touch. Thank you.
And thank you, and sorry for the technical hitch there. We, of course, have just heard from Elia Louis from Airbus Defence and Space, not Astroscale. We will hear from Astroscale later, but the order that we've got is just slightly different. So we've just heard about the Airbus RISMA, Paraspa, and VISPA projects. So thank you, Ellie. So next up, the next presentation will have a video from the Fair Space Hub. And we'll be joined for Q&A, and I'm delighted to say we'll be joined by Professor Sir Martin Sweeting, Director of the Fair Space Hub, and known as the father of small satellites. So now we'll hear from Fair Space. Thank you.
Fair Space is the National Center of Research Excellence, future AI and robotics for space. We have a long-term goal to push the boundaries of the state-of-the-art in AI and robotics technology. We have a lot of scientific objectives to address challenges in sensing, perception, mobility mechanisms, and autonomy for future space robotics systems.
The important part of Fair Space is that actually it's not just an academic research activity. That is, of course, at the heart of it, but it has direct links out into industries, and it will involve a number of different types of industry.
We're interested in supporting AI and robotics because that's an area of the future that will enable us to reduce the costs of doing space activity and allow us to do more, to achieve more.
The ideal future for robotics in space is where we can use robotics to remove the debris that we've created in space and to be able to build and assemble and manufacture satellites in Earth orbit.
Space exploration in the long term will rely co-working between human astronauts and robots.
We're going to have robots assisting humans, building the infrastructure of the moon and planets before the humans arrive, but also helping the humans once they're at these bases.
The leadership of Fair Space Hub builds on Surrey's 40 years of research heritage in space and aerospace engineering. We already have over 30 external partners from universities, governmental bodies, and the commercial world.
The partnership in Fair Space is a key feature, that the universities are closely involved with industry, and therefore industry is driving some of the technology development, using the best of academia and innovative thought.
One of our aim to really engage with the younger generation, with the general public and robotics. I would like to extend the invitation to all of you to take part in this exciting journey with Fair Space.
And thank you for those contributors from Fairspace, and we look forward to hearing questions and answers from Sir Martin later on. Now, this time we will hear from Astroscale, from Jason. Astroscale, of course, no stranger to delays, and so I'll pass you over to Jason from Astroscale for his presentation. Thank you.
Astroscale is a growing business in the domain of space sustainability. We've raised $200 million and have almost 190 staff across the business, and have offices among Japan, the UK, and the US. In the UK, we are a rapidly growing business, which started in 2017, and now we have over 50 staff. Our main focus is on providing services to manage end-of-satellite life, including deorbit for constellation customers. Let me tell you a bit about how we're involved in robotics here at Astroscale. Firstly, I'd like to introduce you to the ELSA-D mission, which launched March 22nd from the Baikonur Cosmodrome in Kazakhstan. ELSA-D is the world's first commercial debris removal mission to go through key demonstration sequences. We launched 2 satellites docked together, and they dock and undock in a series of maneuvers to demonstrate advanced robotic technologies in space. In ELSA-D, one of these satellites is the Servicer, a satellite which is capable of undertaking complex rendezvous in space. It is equipped with a magnetic capture mechanism. The other satellite is a Client, which simulates real space debris and is equipped with a docking plate. The docking plate is a magnetic plate which the capture mechanism docks to. It is something we're actually recommending on everybody's satellite to ensure you can future-proof your satellite in future in case it fails. Capturing space in autonomous fashion is extremely complex. ELSA-D is capable of many advanced robotic operations, such as tumbling capture and search and approach. These are capabilities which open the market to future in-orbit servicing. ELSA-D has an array of partners. The Servicer satellite was designed by the Astroscale team in Tokyo. The Client satellite was designed together with SSTL. The UK operations are conducted here at the National In-Orbit Servicing Facility, which we developed with partners RIA, GMV, and CGI as part of a grant from UKRI. Moving forward, in the UK, we're looking at commercializing ELSA-D through our ELSA-M service. ELSA-M, where M stands for multi-client, means we have to plan to have a service where we can remove multiple pieces of debris sequentially. In other parts of our business, Astroscale is involved in wider robotic technologies. In our Japan headquarters, The ADRAS-J mission, which the Japanese space agency JAXA has funded, aims in the 2023 timeframe to rendezvous with a large Japanese-owned rocket in space with the eventual aim of removing it. Finally, in the US, we are working on life extension services. Our Lexi mission uses advanced robotic arm technology to dock with customers in geostationary orbit. Looking forward to the future, there are estimated to be tens of thousands of satellites launched in the next decade. A set percentage of these satellites are going to fail. We hope our robotic technology we have developed will enable future debris removal services to remove those failed satellites, ensuring we are contributing to a more sustainable global future for space. Thank you for listening. I hope that's given you a good perspective of what we're doing robotics-wise in astroscale.
And thank you, Jeff, for that. For our final presentation for the session, introduce Martin Soltau from Nash Consulting and describing the fascinating concept of space-based solar power as part of a research study conducted on behalf of BESS. I'll remind participants to start questions into the Q&A, because at the end of Martin's presentation, we'll roll straight into a Q&A session before the collaboration session that follows. Thanks.
Hello, my name is Martin Soltau. And over the next 3 minutes, I'd like to take you on a journey into a technology which offers the possibility of transforming both our environment and our national space capabilities. It starts with net zero, the government's legally binding obligation to decarbonise our economy by 2050. And that, of course, is a hugely ambitious aim. And it's recognised that we need to look for new clean energy technologies. Fraser-Nash has recently completed a techno-economic assessment on behalf of BESS of space-based solar power, and our conclusions are that this is both technically viable and economically attractive. It would offer large-scale, baseload and dispatchable power, and with a broad range of favourable characteristics. The levelised cost of electricity is highly competitive compared to other sources of clean energy. In short, it offers the UK new options to deliver and de-risk net zero within a mix of technologies. The development of space-based solar power would also offer the UK economic and spillover benefits if we were pursuing it, and it aligns well with a range of key government priorities. So how does it work? Well, we've studied two of the leading concepts, and the challenges are more economic than technical. A typical solar power satellite would deliver around 2 gigawatts of power into the electricity grid, and it comprises a vast kilometre-scale structure in a high Earth orbit, collecting solar power, converting that to microwaves and beaming it to Earth. Though it's enormous in scale, the satellite is comparatively simple in its architecture, quite unlike a traditional monolithic satellite. It comprises a small handful of standardized module types and a very, very large number of these modules assembled together in space. And this hypermodular architecture does two things to dramatically reduce the cost. Firstly, it allows for very high volume manufacture of standard parts. And secondly, it provides for a well-defined and very structured environment for autonomous assembly. And that's arguably quite a lot less challenging than, for example, robotic exploration of Mars. We have recommended that the government pursues the development of space-based solar power, and that this is integrated into key policies such as the National Space Strategy and Net Zero. The scale of development cost and risk and timescale would mean that public money is required to fund the technology up to TRL 6 or 7, at which point the private sector will increasingly be prepared to take on the development and the industrialisation. The government is actively considering how to take forward our recommendations, and meanwhile, industry and the research sectors are collaborating with the formation of the Space Energy Initiative. If the UK does decide to take a leading role in developing space-based solar power, it could both help deliver net zero and provide the market incentives to transform our capabilities in space robotics. Thank you.
Thank you, Martin, for that. So we'll now go to Q&A. Please do start putting your questions into the chat. We'd be really interested to see what thoughts you've got. We have had one question already. So this is a question for Fairspace. Your presentation mentioned engaging the younger generation in robotics and aerospace. Do you see a role for the arts and humanities in that aim? And we'll go over to you, Martin, for that.
Yeah, well, thank you. Well, it's an interesting question. And I think it's quite a deep question as well, because it covers a wide, I think, range of topics. You know, in humanities and arts, first of all, you know, there's the technical aspect, which is understanding the psychology of space, the interaction of robotics in space with people. At the same time, there's actually quite a thriving community of real space artists. And I think this, you know, sort of brings the two things together, and it perhaps helps fire the imagination of the younger generation. And if they can see that there's, you know, wider opportunities in space than just through the science and engineering, I think that's something that we really want to encourage.
Thank you. And any of the other panelists want to come in there at all? Perhaps we'll bring this up again in the collaboration session. It'd be really good to hear members of the audience in the collaboration session maybe bring some of their own views on that. So the second question we've had in, and this is a really good one, because I do think it's fair to say, and I can have this perspective because I don't come from a space robotics background. Sometimes this sector can be quite inaccessible for people outside the background. So the second question is, how do we collaborate in space robotics without being employed by a space company? I'll go over to, I think the SatApps Catapult might have a good perspective on this. So Laura, how would you approach an individual from a company not involved in space wanting to get involved?
Yeah, definitely, Mark. I totally agree with you with your view of space being sometimes it looks like a little bit difficult and out of reach, but it's totally the contrary. We have different people, not only technical but also business analysts, like different backgrounds that can actually and contribute a lot to the space industry. And in particular with robotics, I think any robotics company would play a vital role in space, because when we talk about doing robotics in space, it's not only about the servicing and refueling that we've seen some examples, but also we can think about all the things that we saw today in the presentations regarding, for example, offshore energy or the nuclear operations. So all these technologies and knowledge from the robotics sector can be directly applied in space. So these collaborations are very interesting, and that's where in Satellite Applications Catapult we really give a lot of importance to these partnerships and collaborations between companies, not only space related, but with other backgrounds.
Thanks, Laura. If we go over to Martin Soltau from Fraser Nash, because Fraser Nash Consultancy obviously doesn't just do space and didn't used to do space. So can you give us a perspective on how your organization actually developed its space expertise?
Yes, thank you, Mark. So we're a broadly based consultancy, and the thing about consultancy is you're really trying to apply problem solving expertise right across different sectors, and very often we can find we can apply expertise from the nuclear sector into the offshore oil and gas, or industrial, or defense and aerospace. We've been working in with the launch sector, helping reaction engines with the design of the Sabre demonstrator engine, and of course their primary market doesn't really exist yet. Potentially it's space-based solar power, where you need very, very high tempo, very low cost, fully reusable launch systems. And so it was through our collaboration with reaction engines that we know all about the energy challenges of net zero, and we put the two together and realized the government needed to look at new technologies like space solar power, and that's how we really got to be doing the space solar power work. But the broader space market is very it's just one of our other markets that we work in, and it's an interesting question about getting robotics from other sectors as well, and other sectors working in this area, it's absolutely the case that space robotics has huge applications in all sorts of robotics for challenging environments.
Yeah, thank you, Martin. I'd offer one other thing, is that something we have seen throughout the Robots for a Safer World challenge is that we have got some examples of companies who are not in the space industry partnering with those that are, sort of recognizing that it can be quite a high barrier to enter. And there are examples like, for example, Tizix Limited, manufacturer of titanium composite components, partnered with Airbus and Defence and Space to provide those materials and integrate them onto a space system. So there are numerous examples of people partnering with space organizations and entering into the market that way. So that's something I would consider if you're not working in a space-based company, but you think you've got something to offer. Come and talk to the Catapult, come and talk to us at Innovate UK, because we might be able to hook you up with people already in the sector. So the next question, this is back to Martin Soltau again, because this relates to space-based solar power. So are there any potential issues with ionizing the ozone layer that come with the transmission of power from space? So we'll answer that first, and then there's a second part to that to do with deorbit. So first one on ionizing the atmosphere.
I think there's a number of environmental issues that do need to be properly assessed. The people have looked at this and don't believe it's a problem, but I think it's certainly something that needs rigorous assessment. There is a number of similar sort of concerns, I think, environmentally, which we weren't the subject of our study in detail, but we did touch on them and ask around the research community, and our feeling was these aren't major problems or barriers, but they do need to be assessed. So it's a good question.
The second part of that question then is what's been done to minimize the impact of huge superstructures as they deorbit? Or in fact, more generally, what are the deorbiting plans for these assets?
So the whole issue of decommissioning is really important. We're actually just about to start a little bit of work with European Space Agency on just this topic. Deorbiting from geo is obviously really expensive, and so people have proposed schemes like potentially a hydroelectric power station. You actually never decommission it; you continue to upgrade it. But it's a good question, and it needs serious study.
We've got questions coming in thick and fast now, which is good. So I'll just pick a few now. So we've got, what role are your collaborations playing in mapping space debris moving in orbit? I guess we'll go to Astroscale first here with respect to mapping debris.
Sorry, apologies. Could you repeat that again?
So what role are your collaborations playing in mapping space debris moving in orbit? We'll start with you, Jason, if that's all right, and then maybe we'll move on to Fairspace.
Yeah, sure. I think this question is pertaining to the use of space situational awareness. So I guess the key question we have in future is there's a lot of space junk up there, and there's a question of what do we actually need to remove. At Astroscale, our end of life and debris removal services, we're normally targeting much larger clients for actual removal. So quite often it isn't an issue of being able to find them because they're so small. There is generally a lot of space situational awareness on the ground. So for example, radar systems or other things that are tracking microfragments as well. And of course, it's the microfragments that are actually very, very dangerous to satellites, because as larger spacecraft collide, they produce these smaller fragments. So whilst it's good for us to track them, it's very difficult for us to actually remove them. That's why we're focusing on, removing the larger satellites that give rise to these smaller things. So hopefully that answers that question.
Thanks, Jason. And Fairspace with respect to mapping debris, is this something that's covered in your research?
Well, I mean, yes, of course, in order to be able to address the debris issue, you've got to know what's there first of all. But it is quite a big problem, as Jason indicated. There are millions of bits of debris, but all different shapes and sizes. So the first thing to do is to sense them, and there are a number of satellite missions which both initially optically detect what bits of debris there are around and map them, because not only do we want to better remove them, but for active satellites, they may need to maneuver out of the way of the path of impending debris collisions. So mapping the debris field is really critical. And this is something that's now I think moving actually into the commercial phase as well. It previously was primarily governments, but now there are commercial initiatives to provide that information.
Thank you, Martin. So the next question we've got is on secure communications. So how do you perceive secure communications and data links will be incorporated within the space environment, and how will the regulatory standards be applied internationally? I think a good perspective here may be Laura from the Catapult, if you can talk about how communications are applied across all forms of satellite, because I assume this question is not just for robotics.
Yeah, so we believe that the communications it's very important, and the data links, they need to be secure. So we do have some projects regarding cybersecurity and how this affects in the space environment and space operations. But I'm not the expert on this, but we can definitely ask someone in the Catapult. I can put the person that asked this question in contact with some experts.
Brilliant. And I think what we'll do is we'll bring that up in the collaboration session, because we may well get people from industry who work in that space that might want to contribute. So, and
I think that Martin also had some comments to add to this.
Go ahead.
Yeah, I sort of flapped for a moment. Just to add to, cybersecurity for spacecraft was something wasn't terribly high on the agenda in the civil field until quite recently. But I think now there's a much greater awareness of the vulnerability, both of the spacecraft, the links, and the ground segment to cyber attacks. And so there's a major move to strengthen and make more resilient those links, and also, of course, to make sure that the data for commercial services is kept commercially secure.
Brilliant. And Ellie from Airbus, have you got anything to add with respect to comms links, but also any of the other questions we've had so far?
Sorry to be muted. In terms of comms links, yes, if we're actually putting a lot of assets in space, and these are actually to be quite critical, both for the orbit, any kind of robotic systems, for manufacturing, assembly, and so on. Comms links are going to be quite critical. You want safety of your system in space. So I think this is one angle where security of communications can be quite critical.
I think actually, if I can add to that, the secure robotics is going to be really critical, because if you have safety of life robotics, eventually, when you're on planetary surfaces, there's not only going to be the issues of the interaction with the space radiation environment, but also deliberate interference. So cyber secure links are going to be absolutely essential with space robotics.
Yeah, I agree.
Brilliant, thank you. There's so the next question directly to Astroscale. The need for managing space debris is, of course, a necessity. Apart from phoretic surfaces, what do you see as other technologies that would aid in the ease of decommissioning at the end of useful life?
Yeah, thank you very much for that question. So I guess we have two key business lines. One's an end-of-life services business line. The other is classical ADR. In the former, we're actually encouraging companies to fit docking plates to their satellites, such that once they launch and need removal in future, maybe due to failure or any other reason, they can actually be easily removed. So that docking plate, for example, enables magnetic capture, but also robotic capture, physical mechanical capture. So I say that these are key technologies used for actually docking, as well as a range of rendezvous and proximity operations capabilities and technologies that need to be matured. These are the key things that are necessary to overall grow the market in debris removal and decommissioning.
Mark, if I could add.
Go ahead, Martin, please.
Yeah, I mean, if we have the two forms of debris interaction, one is cooperative and then there's uncooperative, and those that have adaptation plates which we can use and those which can't. And then, so a couple of years ago, we demonstrated in Surrey the acquisition essentially of techniques for uncooperative pieces of space debris using quite old technology in the sense of it was derived from the Roman gladiators' net and the harpoon. And this was demonstrated in orbit to look at capturing either large or small bits of uncooperative debris. And if anybody wants to have a look for what that looks like, you can look on YouTube under Remove Debris and you'll see a video of it.
Thank you, Martin. So we'll move on to a difficult but very important question about diversity. So if we're to have a diverse range of collaboration in the space industry, do we not need a more diverse set of talent within the industry first? The wash of white men on these panels isn't exactly encouraging for a young person entering the industry. I think it'd be good to get all of your perspectives in turn. And I note that as part of Innovate UK and KTN, we were careful to ensure that we got as good a diversity as we could. We were careful with the way that we invited the panel members to join these sessions. But it'd be really interesting just to get each of your perspectives on what the current state of diversity across both gender and race is within the industry, and what you think could be done to improve it. If it's okay, I'll start with Laura, get your perspective on this topic.
Sure. Yeah, I think it's a very important topic, but I also am very positive about this. I think we're seeing lately a big change. In my case, it's something very personal because I'm actually Spanish. So yeah, I think there's actually another question as well about this. The industry is changing, it's evolving, and we need people from all backgrounds and all diversities. So I think it's changing, and little by little we're seeing more women involved and people from different industries.
Thank you. We'll go to Airbus next.
Yeah, in my experience, we can see at Airbus an extremely varied, diverse population, both in terms of genders, in terms of backgrounds, nationalities. It's extremely multinational, but also very diverse in terms of, we can see all genders across the scale in management, for example, and it's very well balanced.
Thank you. Astroscale, how has Astroscale approached this issue of diversity within the space industry?
I would say that this is one of our key values in the business, to ensure that we have a very diverse workforce. People of talent can come from any background, any gender, any orientation, any nationality, and we definitely try to consider that when we're recruiting. I would add that we're a very multinational organization. We're in Japan, we're in Israel, in the US and the UK, and the people in those companies come from all sorts of places. So we really do embrace this form of diversity, and we really try to encourage those from non-traditional backgrounds or other types of individuals which are non-classical, as indicated by the question, to join Astroscale. Thank you.
Thank you, and we'll save Sir Martin for last, because I'm sure your perspective is unique with the academic involvement that you've got. But Fraser Nash next, in terms of the issue of diversity in the space sector.
I just point to Maggie Adirin-Pocock, who's a great champion really for the sector and diversity. She happens to be wife of a friend of mine who used to work for Fraser Nash. But at Fraser Nash, like most of the companies, it's we actively encourage diversity, and we monitor how well we're doing. And I think the space sector should be attractive to women, and the aim is always to try and get them when they're about 14 and encourage them into STEM at that age, because that's so important when they're starting to make those choices, and particularly about maths.
And lastly, Sir Martin, but I'm going to make your life slightly harder, if that's okay, and I'll ask it differently. So I think it's fair to say that there's still a very long way to go. So what more can be done to make sure, as the person who asked the question, as a young person wanting to enter the industry, what more can we really do to encourage this beyond what we're doing at the moment?
Well, yeah, it is a difficult question, for which if there was a simple answer, I'm sure people would have already adopted it. I think essentially it's making the widest part of our overall community aware of the opportunities. So from, as was mentioned earlier, from a young school age, inspiring people, kids to take an interest in space technology and of course STEM in general is critical. And then it is for not just the universities and education establishments, but also industry, to encourage and use by demonstration, roles that have been developed, and so that kids can see that they have the opportunity to follow similar sort of pathways. I think it definitely is improving, and diversity is absolutely critical. At Surrey, we have, I think it was about a 30% female workforce on average, from many different nationalities. And what I've seen over my career is it is the mixture of nationalities, different thought processes, different approaches, different gender sort of approaches to problems that really is critical. And so, diversity is key. And we just need, I think, to demonstrate the opportunities to young people, irrespective of their backgrounds, whether it be gender or origin or wherever.
Thank you. I appreciate these. These are tough questions to answer, not just for the space sector, but actually across robotics, and we'll see those challenges in a lot of the other sectors that we're involved in. We'll move back to a more technical question now on AI systems. So curious to know about the compute requirements for AI systems in space. AI hardware industry talks about peak operations per second, tops per watt, and inferences per second. Do any of these metrics matter in your world at all? Now, I think this will depend on the extent to which AI algorithms are used, and they are not yet completely commonplace across space. There's a lot of safety critical systems that don't yet rely on them. So let's go to, we'll start with Sir Martin from Fairspace, because I assume you do have more AI in your systems than perhaps some of these more established companies, and then we'll move on to others like Airbus to ask them more on how they're using AI.
Yeah, I mean, and to give others a chance to have some time as well on this, I think that the way I would approach this is it's not just AI, it is how much computing you put at the edge, if you like, of your space hardware. And then you have to look at the total energy equation. So how much energy are you having to put in to the computing capability versus if you were to transfer that computing capability to the ground? Because spacecraft tend to be limited in the amount of power. There are thermal limits, there's radiation environment limits. And so there's always this balance as to how much computing capability can you afford to put in your spacecraft or in your spaceborne robotics, as opposed to having that computing facility remotely on the ground. Each of those has its constraints and issues. And so it's a continuing balance, and the consumption of large processing, not just the capability in flips and flops, but also in the thermal issues that can be quite serious when you're working in a space environment.
Thank you. We'll move to Airbus now. So what are your compute requirements at the edge?
I think this is a quite difficult question. As an industry, we try to walk that tightrope between heritage, what we can actually fly, and the new requirements coming up through new use cases. So as a company, we're looking at both at teleoperation, but also we're deploying things on Mars, for example, that are more autonomous. So there's the whole spectrum in between where we have things teleoperated, then guarded teleoperation, where we just facilitate the life of the user. And we're looking at different scenarios where the user has it like simplify. If you want to assemble things in space, then there are ways you can actually simplify the life of the operator, or have the operator kind of perform more of a supervisory role and all of that needs some sort of AI, some autonomous elements in space. And yes, we need the computing power to actually do that. We need smart software to actually do that in a very efficient way as well. So all of that is kind of all rounded in this kind of use cases.
Any other comments from the panel on compute requirements? Laura? Oh, no, go ahead, Jason.
I was going to say, just to give a bit of the astroscale perspective on AI and systems, completely agree here with Sir Martin on the need to understand the trade-off between whether you do processing on ground or processing in space. Our current mission, LCD, we have a mix of both onboard processing and on-ground processing. And for the onboard stuff, that's often things that has to be processed very, very quickly. So a mix of sensor-based processing that you need to do very quickly in order to, navigate and perform your control algorithms and things like that. On ground, our processing are things mainly for flight dynamics, for MPS, which is the mission planning system, things like that do take up more processing power, but that's why they're on the ground. So it is the mix of getting the balance right between space-based and ground-based processing, and that ties into the concept of operations of how you design your overall mission and where you actually place your autonomy overall in the mission sequence.
I think there's also a bit of a growth towards a trend towards edge computing now applied to spacecraft. We see it on the internet and on terrestrial systems, but as we get more intelligent sensors and actuators, we are now seeing a shift to edge computing around the periphery of spacecraft and robotics.
Thank you. So if I've missed your question, what I'd do is I'd encourage you to join the collaboration Zoom call. It's possible if you've put your name to your question, maybe you're talking about how your own business might be able to contribute. It might be best for you to raise your hand and raise that in the collaboration session so you can introduce yourself. So if you've not had your question answered, please do raise it there. I think there's probably time for one or two more. So we'll do the next question then on, from an education perspective, how do you see the transitioning of how to educate future young workforce in the sector? And then it says, and the manufacturing of increased volume of removal of debris. So I think this, if we take this as a skills question, how can we improve the education of future young workforce to improve this, fill the skills gap in this sector? If I've not interpreted that question right, again, I'd encourage people to go to the collaboration session to bring that up again. Any volunteers?
I don't mind starting that. From a slightly different perspective, I think you need programs, funded programs, to generate the kind of the funding and the business, which then young people will move into and also take excitement from. And debris removal it's difficult at the moment to see what the market is, apart from obviously we want to try and improve the environment, but who's going to pay for that? One of the points about space solar is that it's an energy market which will need autonomous robotics and so forth, and there's a very, very clear client who would pay for that, and that may be one way of both exciting people to come into the sector and also developing the businesses that are going to be give them those jobs and opportunities.
If I may, I think in terms of moving forwards and educating, I think we are moving now. We're transitioning between a time where we would actually launch things and just leave them there, to maybe a time where we need to think about reducing, reusing, and recycling. Initially the default was we need to kind of bring everything back, but ideally we've actually spent money to actually put it there in the first place. Is there a better way to use these things when they're there? Can we swap payload, reuse the platform? Can we do something else with it, put multiple payloads on it? And I think we need to transition towards that rather than this kind of debris well, debris removal is going to be one aspect of it, but I think not necessarily just that one aspect.
Totally agree there, Ellie. And I think that we're seeing more and more in-orbit servicing, not only the removal, but the part of the refueling and also manufacturing. And this is going to be key for the in-orbit economy. And in order to have many companies, not only government funded and agencies, but other organizations contributing to this in-orbit economy that we will have. And going back to the skills part, actually in Satellite Applications Catapult, we are looking into this in a lot of detail. We're having some proposals about skills academies in which it will not only be the theoretic part, but also maybe having some capabilities so that people can learn by doing with more practical approach, and we can do some modeling simulations and even real hardware so they can test and they can learn by doing. That is always the best way to learn.
I would thoroughly endorse that, Laura. It was exactly what I was thinking. Getting young people involved with practical activities is the best way to catch their imagination. Coming back to the first question about what do we do all this stuff that we've launched into orbit? I mean, I think if we look, this decade is going to see a real change in the whole way, in fact, a revolution in the way we approach space, because the combination of new launch systems, but also particularly space robotics, will mean that we will be able to have in-orbit assembly of spacecraft, and then a little bit later on, in-orbit manufacturing. I mean, if you think of it very crudely, of launching a 3D printer and then the raw components, and off you go, you manufacture your satellite in orbit. The stage after that, of course, is to say, well, we've got all this hardware in orbit, can we then recycle it? So rather than launching materials to make new spacecraft, can't we harvest some of the materials that are already in orbit and then reprocess them and produce new spacecraft out of that, so it becomes a self-sustaining activity to a great extent? I mean, that's obviously some decade or two away, but it's not science fiction.
Fantastic. Thank you for that final contribution, Martin. I think we'll now move into the collaboration session, and I think that was a great way to end those questions. As I mentioned, if I didn't ask your question now, feel free to ask it directly, and feel free to make your own contributions if you've got something to add to what we've discussed in the collaboration session. Should be much more free-flowing. Everyone should have the opportunity to pitch in. So I look forward to having you guys jump over to the collaboration session now. There should be a separate Zoom link available via the website. Thank you very much, everyone. And thank you, Pam.